So now we want to start looking at factoring, which is kind of the opposite of multiplying. So in the multiplication problems, what we were doing was we were multiplying two polynomials together to get some expression. Like in this case right here, right, we had x plus 4 times x minus 4 equals x squared minus 16. So now we want to take that x squared minus 16 and turn it back into the x plus 4 times x minus 4. So we want to break them down into what we call factors. So how do we go about doing that? Okay. So the simplest form of this would be if everything has a common factor. So let's just think about numbers first of all, before we throw variables into the equation, right? If we think about like 5 and 15, okay, these two numbers, what would we say is a common factor of these two? Right, well, they have two common factors. They have 3 and, or sorry, not, they don't have 3. They just have 5, right? So they both have a factor of 5. And what we mean by that is that they're both divisible by 5, right? So we can take 5 out of both of these. So if we had something like 5x plus 15, then we could go ahead and take 5 out of both of these. And what we mean by take out 5 is that we would divide each term by 5, but we wouldn't just get rid of that 5. We would instead kind of bring it out front. And we would rewrite this as 5 times whatever's left in the first term when we divide by 5, which would be x, and whatever's left in the second term when we divide by 5, which would be 3. Okay. So it would be more proper to write it just like this. 5x plus 15 is equal to 5 times x plus 3, which we could verify with the distributive property. So we're looking for some number that we can divide every term by, but we're not dividing it in that we get rid of the number. We're just bringing it out front. Okay. So we're typically looking for what we call the greatest common factor, or GCF. And of these two numbers, for example, it would be 5, right? We can factor out any common factor, but in general, we want to factor out the greatest common factor, meaning the largest number that they both have in common. Because, we're generally doing it to make the numbers as simple as possible. So why wouldn't we go for the largest one? So if we have something like 2x squared minus 14x plus 8, for example, every term in this polynomial is divisible by 2. So we'd say the greatest common factor is 2, and we pull a 2 out of everything. So we'd have 2 times x squared minus 7x plus 4. Okay, so we're dividing each term by 2, and we're bringing that 2 out in front. Okay. So when we start throwing variables into the mix, if we say what's the greatest common factor of x and x squared, we really mean it the same way. We're looking for the largest variable that they both share in terms of their power. So here, the largest one they have in common is an x, right? X to the 1 power. You could take x out of x, of course, and you can take x out of x squared because there's 2 copies of x here. So if we had something like x squared plus x and we wanted to factor it, we could pull an x out and we'd be left with x in the front because we took one of the x's out, and we'd be left with 1 right here because x divided by x would be 1, right? Anything divided by itself will be 1. So we can do this with variables just the same way that we would do it with numbers. Maybe we combine them now. What if we have 5x to the third plus 15x squared? Now we can take a 5 out of both of the numbers, and we can also take an x squared out of both of these, right? X cubed is equal to x times x, which is x squared times x. So there's an x squared in there, in that x cubed term. So we can take an x squared out of it, and we'll be left with just that other x. Okay. So we get 5x squared times, here we're just left with that x, right? We took the 5 out, we took the x squared out, so we're left with this x here. When we take 5 out of 15, we're left with 3. And we take the whole x squared with us, so we have no variable part left. So we get 5x squared times x plus 3. Okay. Now, sometimes the functions are set up in such a way that maybe we can take a factor out of both things, or all of the terms, and then it's what we're left with is something that we can factor again. So this is kind of a special case called factoring by grouping. Okay. So let's say maybe we have something like x cubed plus 2x squared minus 9x minus 18. Okay, we'll just leave it like that. Now, there's nothing that we can pull out of all of these. But what we could do is we could pull something out of the first two and something out of the second two. Okay, so let's do that and let's see what we get. So namely we can pull an x squared out of the first two terms, right? X squared is x plus 2 times x plus 2. Here we can pull a minus 9 out. So you kind of have, when you have this negative, you kind of have a choice if you want to take the negative out or not. Here we're going to do it because of what we're going to be left with. When we take the minus 9 out of minus 9x, we're just left with x. When we take minus 9 out of negative 18, we're left with a plus 2. So what happens here is now both of these terms have a common factor. Right, so this has an x plus 2 and this has an x plus 2. So now we can pull the x plus 2 out of both of them. Okay. So they're sharing this x plus 2 here. Okay. So we're going to take that out of both of them. And here we're going to be left with x squared. And here we're going to be left with minus 9. Okay. And now it is factored, and we can actually factor this a little more. We'll cover this on its own video, but you might notice this is a difference of squares right here. So this is x plus 2 times x plus 3, x minus 3. But like I said, we'll cover that on its own video as well. So just to recap the steps for factoring by grouping, you're typically looking to factor something out of the first two terms, factor something out of the second two terms, and then that should leave you with a common factor that you can then pull out of the entire thing.